So, hello student, I am Surit Mahalsekar, your instructor for this particular course. Before starting with lecture 1, I would like to tell you that what all things that we will be studying in this particular course. So, starting with the course, we will be studying with some of the basic concepts like some of the basic concepts of electrical circuits like what is current, what is voltage, power, resistance, etc., etc. After that, we will be studying certain laws like Ohm's law. Then we'll deal with series parallel circuits, then KVL cases rule, etc., etc. And then we will be seeing some of the techniques which are required to analyze the circuits. And we will at the same time we will also look at the simulation part. The simulation part will be performing in one software which is known as Thinkercad. For this, you require a good amount of internet connection and you have to sign up. Just type on Google the Thinkercad software and then sign up on this particular website. Okay, but this particular simulation part we will be discussing after 4 to 5 or maybe 5 to 6 lectures. Okay, so now we will be starting with our lecture 1. So starting with the first topic is some of the basic topics which I think it is important to start with is this, like conductors, insulator and semiconductor. I will just give a basic idea. So conductor is a material which can transfer heat and electricity through it. Okay, so what does that mean is, consider that this is your conductor. Okay, and this is your conductor. I am denoting it with C, and when you are applying heat or electricity from one end, let's say this is point A and this is point B, so this heat and electricity gets transferred to point B. Okay, so this is basic idea of what conductor is. Now talking about insulator. So insulator is a material which cannot transfer heat and electricity. So what does that mean is, consider that this is an insulator. Okay, and you are applying some heat and electricity from one end, heat or electricity from one end. Let's say this is point A and point B, and but other end you are not getting. Okay, you are not getting any heat or electricity. So this is basic idea of what insulator is. That means it does not allow transfer of heat and electricity. And semiconductor. So this is very vast topic, but just to give a short idea that what it is, we'll just say its definition. So semiconductor is a material which is a combination of both conductors and insulators. That means what this particular line means to tell you is that at certain condition it will behave as a conductor, and at some other condition it will behave as insulator. So basically this is very vast topic, and this particular topic, that is semiconductor, I will be covering this topic in my course 2. Okay, so in course 1 we won't be studying this particular part. Okay, we won't be studying this particular part. Okay, so now moving to the next page. Okay, so these are some of the examples of what conductors and insulators are. So as you can see, it's silver, gold, copper, steel. These are the some of the examples of conductors. While this like rubber, glass, oil, diamond, and wood, these are some of the examples of an insulator. Okay, there are n number of examples available, but you can see it on Google, or I hope you know these concepts. You had already studied, but still I'm revising it. Okay, just to give a little bit idea. So now there is one question. There might be one question which might stuck in your mind, that how a conductor is able to transfer. Just a second. Okay, how a conductor is able to transfer heat and electricity, and why insulator fails to do so. Just try to think. Just try to think this particular thing, that okay, how conductor is able to transfer heat and electricity, and why insulator fails to do so. Just pause this video and try to think. Okay, so now we will see the reason for it. But before seeing the reason, I would like to explain some basic thing. Okay, so we all know that in conductor there are n number of atoms. Okay, just forget that. Okay, So we all know that atom has nucleus which has positive charges or protons in it. Okay, so consider that this is the nucleus. Okay, so this particular part, it is a nucleus. Okay, but in conductors, the attraction between the nucleus of atom and the outermost electron or valence electron is less. So what basically this line means is that, see, this particular thing, that means is the attraction between this outermost electron. So basically this is our outermost electron, outermost or valence electrons. So the attraction between outermost and valence electron is less. Extremely sorry. The attraction between the nucleus of atom, this is nucleus, or you can say that it contains positive charges. Okay, the attraction between nucleus of atom and the outermost electron or valence electron is very less. Okay, therefore what we can do is, by providing certain energy, now energy can be heat or electricity, that doesn't matter at all, but what we can do is that by providing certain energy we can remove this particular electron from this atom, as you can see over here. Okay, so we had removed these electrons from that particular atom, and thus this atom has gained some positive charge or positivity, and this particular space is known as vacant space. Okay, I hope you understood this. I'm moving to further page. One case of insulator. Okay, and in an insulator, the attraction between the nucleus of atom and the outermost or valence electron is very high. What does that mean is, see, this attraction between this outermost electron or valence electron, I will say valence electron, and this is your nucleus, and the attraction between both of them is very high, or high I will say. Okay, and due to this, even after applying sufficient amount of energy, or rather applying some high amount of energy, that means even if we are passing more heat, energy means more heat or much more electricity, this electron doesn't move out of this shell because the attraction is very high. As you can see over here, the electrons revolve around the atom, it does not move. Okay, so what our question was, how a conductor is able to transfer heat and electricity, and why insulator fails to do so. Okay, so now we had got the proper answer. How? See, in case of conductors, okay, in case of conductor, what was happening is that, since we are able to remove these electrons by applying certain energy, so now let's say energy means maybe applying heat or applying electricity. So let's say we are applying heat in this case, okay, due to which the atom is losing one electron. Okay, so obviously this electron is lost. Okay, and just consider that this is a conductor, and this conductor has only one atom. Just assume that, and due to which by applying heat or by applying some energy, this electron is loose from this particular atom, and now it can move. Okay, and now it can move. So basically, consider that this is point A and point B. So basically, these electrons can move from point A to point B. Or what we can say is that heat is getting transferred from point A to point B. Are you understanding? That means electron is serving as that medium to transfer heat or to transfer electricity in conductors. While in case of insulators, consider that this is an insulator. This is insulator. Okay, and this is point A and point B. Now, even if we are applying high amount of heat than what we were applying in case of conductors, this electrons is not loose from this atom. See, the electron, we can't remove this electron from the atom, and therefore the electrons can't move from point A to point B. That means heat cannot transfer from one point to other point. So that's why insulator acts like a good a resistor, or basically it does not allow heat or electricity to pass through it. So this was the basic idea. So I hope you understood and you got the answer that how a conductor is able to transfer heat and electricity and why insulator fails to do so. Okay, I hope you got the answer. Now, okay, so we will try to just do a small experiment. Just consider that this is rod 1, which is a metallic rod. Consider that it is metal rod, and it is made up of iron or copper. You can take anything, iron or copper. Okay. So when we rub this rod on cat's fur, okay, just a second. Okay. So when we rub this rod on cat's fur, it will store certain negative charges. Okay, it will store certain negative charges, and we are seeing it with the help of microscope. Just think that, or just assume that. Okay, so my question to you is that what will happen if you touch this rod to a conductor and an insulator? Okay, what will happen when we touch this rod to a conductor and an insulator, or and an insulator? So just think, just pause this video, just think, and then give me an answer. So I hope you had thought your answer in your mind. Okay, now we will see the proper answer for it. Okay, so now what will happen is that when we touch this rod to a conductor, the transfer of charges, or I will say the transfer of negative charge takes place, due to which the conductor, suppose this particular part gains some negative charges. That means the transfer of charges takes place from this rod to a conductor, and then this particular rod, this particular rod will lose some negativity. Okay, after some time, again it will, if you can see through microscope, it has transferred some charges. Okay, and then it will again lose some charges from this particular part. Okay, now, and this process goes on further. Okay, I hope you are getting me. I hope you are just getting that what I want to tell you. Now suppose this is that rod 1 again. So this is rod 1. And again I had rubbed this rod to cat's fur, and it has some negative charges. Okay, but now in this case I am touching this rod to an insulator. Okay, maybe that insulator may be a rubber or maybe a diamond, that doesn't matter at all. So consider that this is your insulator. Okay, so what will happen in this case, since the electrons present in the insulator atoms are tightly bonded, therefore this electrons, that means consider that this is the atom of insulator. Okay, it has outermost shell, and that outermost shell has one electron. Okay, I know that there are many electrons, but for understanding this concept, we are taking just a single electron. And now, as I am touching this rod, so what will happen is that, let's say this particular negative charge, just a second, I will use some different color. Okay, so let's say this particular negative charge is trying to come towards this insulator. Okay, now as soon as it let's say comes over here, so now you can see that insulator also has negative charge, and this rod 1 also has negative charge. It is trying to move over here, and these electrons basically trying to repel this particular negative charge, due to which what happened, the electron from this rod 1 cannot get transferred to this particular insulator, and therefore electrons cannot get transferred from this insulator. I hope what I meant to say, I hope that you are able to understand this. While in case of conductor, what was happening is that let's suppose that when we touch this particular this particular negative charge came over here. Wait, I will draw another this atom, and it has a nucleus, okay, and it has electrons, okay, and this is a negative charge which is coming from rod 1. Now what will happen is that it is trying to come over here, but now in this case the energy of this electron, that means the attraction, as I said, the attraction between the nucleus of atom and electrons of a conductor is very much less, therefore they will repel each other, but in this case this electron is moved out, okay, and that's how the transfer of electrons takes place. That means let's say if there is another atom, okay, it has a nucleus and it has one electron, okay, and now this electron which has moved out, it will try to come over here. This will again repel each other. Now this electron will come out, and then again let's say if there is an atom, it has nucleus and it has electron. So in this case, this electron will try to come here, and then this electron will move out. So thus the transfer of electrons takes place from this conductor, and it fails in insulator because the attraction between electron and nucleus of atom is very much high. So I hope whatever the concept we had studied in lecture 1, you had understood it. Now we will meet in lecture 2 with some new concept. Thank you.